Okay, so we're here taking a look at the pulse generator, and the pulse generator is now connected to the oscilloscope through this BNC cable here, and all the way to this T. So this is a very short BNC cable. You can see this is a very short BNC cable. So the pulse that is being generated right now is a 300 nanosecond pulse. As you can see here, we have 100 nanoseconds per division, and therefore we have a 300 nanosecond pulse, and we have a little bit of ringing because the oscilloscope is now set at 1 megaohm internal resistance. And I'm gonna talk about what is the effect on poor termination, especially in long wires. So here you can see that we have this BNC connector that is called EW trigger, and it runs all the way through here, all the way through the lab. And let me show you over there. Trust me, it goes all the way over here, and then it comes back, and then I just routed it back here so we can handle it at the same position. So you can see here it's quite a long piece of cable. It's got a little bit of several windings left here, and then it's dangling around here, and there is no termination. There is just a BNC jack without any termination. So it's an open piece of wire. And now I'm gonna show you what happens when I connect this cable to the oscilloscope. So I'm gonna connect the cable to the oscilloscope, and now you can see that this weird thing is showing up in the oscilloscope, and this thing here is exactly the reflection of the pulse interacting with the pulse in the source. So through this short piece of cable, we are measuring the what is happening in the source, right? So the pulse that was the original pulse, which is this one, right? So this original pulse is traveling through the cable and being reflected back here, right? So because this is open, so it's being reflected back here, and then it's coming back all the way here and interacting with the pulse that is coming. And since there is a delay, this is what you see. You see a two-step pulse, and then it falls back down here in one step. So the travel time here is roughly 150 nanoseconds. We can actually measure this with the scope, right? And yeah, I don't know if you can see it. Okay, 160 nanoseconds, and therefore we can actually measure how long is the cable based on the speed of the wave travel through this cable, which is roughly 200 million meters per second, which is roughly 0.66 of the speed of light. So because of that, we have this weird signal happening here, and imagine if that was your actual signal, right? Okay, so now it's a little bit better because now I can handle with both hands. So I have this termination here, and I'm gonna place two 100 ohm resistors in the termination, and let's see what happens, right? So I'm trying to terminate the termination, and now I'm touching the termination, and voila! You can see here, without the resistors, with the resistors. So two 100 ohm resistors in parallel, as I'm connecting them, is exactly 50 ohms, right? So 50 ohms matches the termination with the transmission line, and that's the reason why you see this. And if we take out one of the 100 ohm resistors, then we still have some sort of reflection, just a small bit of reflection. So you got to make sure that you have a proper termination, and anything that mismatches the termination will generate some degree of reflection. Okay, so I hope this explanation helps you to understand what is the importance of a proper termination in an oscilloscope system. Okay, thanks, and bye-bye.